We all, at some point in our lives, look up into a clear night sky and wonder, what is this all about? Where do we come from? And what are we made of? Since the dawn of human curiosity, we have contemplated existence. We gaze into a star-filled sky and wonder, where do we come from? And what is life all about? Amazingly, in the past 100 years, scientists have begun to piece together and resolve at least some of these questions. In the core of a star lies the heart of life. Our sun is an average star. Most of the stars you see in the night sky are like our old friend. Stars like the sun will burn for billions of years. Our sun is about 4.5 billion years old and will continue to warm our planet for another 5 billion years. The energy source of stars is nuclear fusion. For the vast majority of a star's life, hydrogen is fused into helium. Huge amounts of energy are created as mass is converted into heat and light according to Einstein's famous equation E equals mc squared. Over the eons, the vast supply of hydrogen begins to dwindle, and larger elements are formed by fusion of helium and hydrogen, creating lithium, and then carbon, nitrogen, and oxygen. In fact, all of the elements of life. Finally, iron is formed, at which point no more energy can be derived from nuclear fusion. This is because iron is the most stable nucleus, and the masses of protons and neutrons in it are at a minimum. No more energy can be squeezed out of them. The star will cool, and gravity causes the star to contract. As it does, friction causes it to flare up and swell out in the form of a red giant, engulfing all of the inner planets and ending life as we know it. This won't happen to our sun for about 5 billion years, so no worries at the moment. A star like our sun will then cool and become a white dwarf, hoarding all of the elements it has created in a 10 billion year life, cold and lonely. Bigger stars go on to share the wealth, creating new treasures in a supernova explosion. Large stars, about 10 solar masses, burn hydrogen into helium, carbon, nitrogen, and oxygen, finally into iron by thermonuclear fusion, just as the sun does, but in a much shorter time frame, millions of years instead of billions of years. As nuclear fusion slows down, the star collapses, and the gravitational forces are so large, electrons are compressed into protons and create neutrons. A sudden release of tiny particles called neutrinos cause the star to explode, and this exploding star is called a supernova. Supernova explosions provide energy to forge the heavy elements from iron to uranium and disperse a periodic table of elements into space. In some cases, these elements form new stars and even new solar systems like our own. We are all stardust. We are all children of the same exploding star. The remnant of a supernova is a neutron star, an object the size of a planet that has the density of an atomic nucleus in the range of billions of tons per cubic centimeter. That's a volume about the size of a spoon. Finally, the most massive stars burn through their nuclear fuel at an astounding rate, forming all of the elements hydrogen through uranium. The remaining core of these stars are so massive that the gravitational force is crushing. Electrons combine with protons, creating neutrons, and still gravity squeezes even the empty space between quarks, and the entire star, one that was hundreds of times larger than our own sun, is compressed into an object of insanely high density. Densities and gravitational forces so high that light itself cannot escape, and thus are called black holes. Black holes lurk at the center of galaxies. Billions of stars circle around these black holes, eventually engulfed by them. So that's a quick summary of all the lives of stars and the origins of Earth and life on Earth to boot. I hope you have found this tutorial helpful, and the next time someone asks you what's the job of stars, you will have a long and lengthy answer for them.